Hopefully everybody can see my screen.
Nice.
Okay, great. Okay, so once again, hello, hafade, and aloha. Thank you all for joining us again today. Welcome to the fourth webinar in the Pacific Desk webinar series. I am David Hitzel, the Pacific Desk Guam instructor. So today's topic of discussion is surf forecasting and reporting. Again, general webinar procedures are, this is being recorded for educational and documentational purposes and will be posted hopefully simultaneously on Facebook Live. Please leave questions in the comment section, so you can do that at any time, and then we'll address your comments at the end of the talk. You can also ask questions at the end of each talk too, if you'd like to wait and do that. And then please refrain from using your video or audio during the talks. Lastly, the video recording will be saved to view later on our Facebook page, and will also be posted on YouTube, and you can access the link through our website. So before we start, a couple advertisements. I mentioned last time that we have another webinar coming up that deals with emerging satellite techniques. So that will occur sometime in mid-November. And then secondly, what I'm putting together now is I'd like to do one or maybe webinars that where we do a office virtual tour. So
oh, cool.
So even during the best of times, most of us, I don't think, get to visit the offices of our peers. So we might as well take this opportunity during the COVID era to visit each other in the offices and meet some of the staff we may never have seen before. So if you're interested in participating in that, then please email me or email Ginger, or get in contact with us through our website. Okay, so I'm very happy to introduce my two speakers today. So on our panel today is first going to be Gary Kewley, who is the CSO of the longest running surf reporting network in the world, the Surf News Network, which is based here in Hawaii. He's been involved with Surf News Network for 40 years, since 1980. SNN actually started in 1976, 44 years ago. So it's literally an institution in local surfing culture. Before that, Gary was camp director at Camp Mokuleia up on the North Shore, and he lived atop Waimea Bay at the time, and he was a teacher also at Wailua High School, where he taught math and English. And our second speaker today is Patrick Clemens Caldwell, who caught surf fever at age 12, and that immediately led to an interest in meteorology. He says the fever continues to the present with stand-up paddling because age happens, and kite surfing being the Pat got his education at Florida State University. He got a Bachelor's of Science and Master's of Science in meteorology. And after that, he worked as a computer programmer for the Department of Climatology and Marine Environmental Protection Agency of Saudi Arabia. So I don't know if that is how much surf is in Saudi Arabia. But since then, since 1987, Pat has been the NOAA NESDIS National Centers for Environmental Information Liaison for Hawaii and the US flag islands in the Pacific. And he is also the National Weather Service surf forecaster for Hawaii. Also, Pat's family claim to fame is that he's related to one Mr. Samuel Clemens, known to most people as Mark Twain. So why are we here today? Why surf forecasting, and why do meteorologists forecast surf? Like, isn't that just for surfers, a fringe portion of society? After all, as far as I know, surf forecasting isn't offered in any college curriculum that I know of, and frankly, I think it remains a mystery to most surfers how surf is forecasted anyways. However, the National Weather Service forecast surf because it is an essential part of the NWS mission of protecting life and property. So for instance, Hawaii averages 300 to 350 deaths per year from drowning, 80% of which are in the ocean. That's not necessarily to say it's always surf, but probably surf is a factor. Rip currents are also a common cause of surf zone fatalities along the east coast of the United States. And high surf can be a hazard to recreational boat users, local transportation, and may cause property damage as well. Whereas on the mainland, coastal states only have a portion of the population directly interacting with the ocean. But for us here in Hawaii and our Pacific Desk students, interaction can be on a daily basis. For many of the Pacific Islands, swells and surf affect shipping, commercial fishing, and local transportation. And then many in the islands live right along the coast and are therefore concerned with a combination of high tides and large surf. This is particularly true for those who live on low-lying islands like those in the Marshalls. And here in Hawaii, a large portion of the population uses the ocean for recreational sports. So for these reasons, I think it could be argued that surf forecasting is an important discipline of the Pacific in the Pacific Islands on par with tornado forecasting for the Midwest or blizzard conditions for the Northeast. Because of that, in our Pacific Desk training, we cover quite a bit of marine and surf forecasting. So in Pacific Desk Level 1, we introduce the students to basic wave components, wavelength, period, height, things like that. Then we go into basic wave generation. So wind speed, we discuss wind speed, fetch, and duration. And then we talk about the life cycle of surf. So the seas, swell, and surf phase. And then we also introduce the concept of the significant wave height, which is the Rayleigh probability distribution as applied to wave heights. And then in Pacific Desk Level 2, we go more into depth with wave theory. We give definitions of wind waves and what gravity waves are and how they relate to each other. We also discuss things like group speed and phase speed, how you calculate them from the wavelength and period, and then how you can use them to estimate arrival times of swells. And then we also go into more detailed explanation of wave generation, starting at the capillary wave phase, how waves build from there through friction. We introduce the concept of fully developed seas, so how wind speed and fetch and duration, how they can be maximized to create your largest swells. And then lastly, we discuss rogue waves and how, on the tail end of that Rayleigh distribution, you can have certain waves that are much bigger than the other waves in the group. We also offer a surf forecasting lab where they can put some of these concepts into practice. The lab also focuses on concepts like dispersion, angular spreading, and energy dissipation. And then also, how to based on distances using great circle routes, factors like island shadowing as the waves travel, and then also wave climatology, knowing which kind of swells to expect and the size of them based on what season it is. And then lastly, we also look quickly at wave modeling, how to make use of the text point forecasts, how to make use of the spectra, how to read the spectra. And then we also talk about the strengths, weaknesses, and biases of these models. So the obvious strength is that they cover the whole basin, not just certain buoy points out in the ocean. But there also are weaknesses. So these wave models are, of course, dependent on weather models. The weather models don't predict correctly, then the wave model is not going to be predicted correctly. And then also, and lastly, the models have sort of known biases, and you have to use them for a while to learn these biases. But once you do, then you can make accurate predictions with them. Also, because of our unique location for our training in Hawaii and Guam, we're able to take our students and actually do physical surf reporting. And during that process, we can discuss concepts like the types of breakers that there are and the kinds of shoaling that produces them, how we determine height and period as observers, and also things like shadowing and shoreline orientation. So we usually take the students to one side of the island to do forecasting, and then the other side, and discuss how, you know, we're seeing swells from different directions, and because of that, they can be different sizes. And okay, and then two more things. The first is communicating surf information to the public. So Pacific Desk doesn't only train in meteorology, but we also do communications training. And part of this training, so this relates to Gary the most, because he's the one that's doing the daily presentation to a large audience. So one of the first rules is know your audience and adapt your message accordingly. So based on who you're talking to, you know, the people that Pat talks to are a little bit different, have more background in meteorology, so the way he presents his information is a little different than Gary, but they're both conveying the same topic. The second thing is repeat the message. So studies in psychology, in terms of memory, they say, you know, most people need to hear things 3 times or read things 3 times for it to really sink in. Also brevity, you want things to be concise. And then the last one, Gary's very good at this. So most people probably these days are getting information from Surf News Network through the internet, but Gary also does a phone messaging service, and he does radio broadcasting on a daily basis. Okay, and then lastly, I found this quote from Pat a long time ago and included it in the surf forecasting, in the text for the course. And I put it there because it's really, really concise, and it's good if you're a junior surf forecaster and you want to check whether you started to practice, you want to check whether you're doing it right. You just need to go back to this quote and check off the pieces there, because it really tells you about 90% of what you need to do. But the other thing I wanted to point out in here is the idea of the intuitive statistician. I found an article from Sweden a number of years ago that I really liked, that described the weather forecaster as intuitive statistician. So that means that it's partly data, but the intuitive part's not so much in terms of feeling, but in terms of you got to memorize patterns. So the point is, the more you practice, the more you try to do surf forecasting, the more you practice, you look at the data over and over, you're gonna remember certain patterns, and that's gonna come back almost subconsciously, almost intuitively, to help you with your future forecasts. Okay, so with that, I would like to turn it over to Gary.
Okay. Do you want me to do just a quick intro?
Yeah. So you want to share your screen?
Oh, it's not shared right now? You don't see me?
It's showing my screen. So at the bottom, there's a green arrow.
Hold on.
Hold on a second. Maybe I gotta release this.
I don't see a green arrow here. Hold on. I'm on that. I don't see a green arrow. I'm not visible.
At the bottom of the Zoom screen, it says share screen.
David, he mentioned he was just going to talk. He wasn't planning on showing slides or anything.
No.
Okay. Well, that's okay.
Yeah, I don't have I didn't have anything. I mean, I just talk basically, you know. So we've been broadcasting on about 30 media affiliates for the whole state of Hawaii, which you can imagine the variation between all the surf spots. It's like, you know, a traffic report over here in Honolulu. You're coming in from Hawaii Kai. It's a lot different than if you're coming in from the west side. So we kind of tailor our reports accordingly based on the overall swell. For example, this current swell that we have over here has it's like about 3 feet overhead right now, but spots like Makaha will be coming in head high. It hasn't been correlating quite as much as you would think. You would think it'd be a little bit bigger out there. And then and then spots that are wrapping around to the windward side up by Turtle Bay Resort. I'm not sure if anybody's much familiar with it, but it will decline rather quickly on a northwest swell. So David, what you're talking about intuition, kind of gathering the overall swell information and then parlaying it to communicating to, all those different niches out there. We have over 100,000 ocean sports enthusiast surfers here in Hawaii, and they're sort of particular, so we tend to be maybe a little conservative. We would rather slightly undercall it than overcall it. For example, if it's, like this last swell, borderline, like say yesterday, maybe borderline, I don't know, Pat, 6 feet Hawaiian scale, maybe double overhead or so.
All right.
Yeah. So, you don't want to call that, anything bigger. The surfers will get upset. So we're sensitive to surfers and their preferences. Especially, it's interesting. Pipeline will be they're hyper conservative on their estimates. I mean, Lordy, you could have a wave come through there at 8 feet, and some of the guys will be out there calling it 3. So, but they're riding pipeline, so we give them a little bit more respect. But we're still not going to call if it's solid 3 to 5 feet. We're not going to call it 3 no matter what, because there is a safety aspect to what we do. A lot of people are hearing our reports that are newbies. And let me tell you, with the virus, there's been more new surfers hitting the water with the advanced people than ever before. So we like to talk to, the different stages of surfers, from novice right up there to the best in the world.
So you're saying there's a force of like public perception that factors in.
Yeah, we want to, tailor it. The local surfer with experience here, they take pride in their local breaks and how they talk to themselves about it. For example, a very localized spot would be Makapu'u on the, the northeast corner of the island, and Sandy Beach. There are really a bunch of talented, athletic people out there you never hear about. They're phenomenal talents out. For example, Sandy Beach, the body surfing. I've seen some of the greatest acts of athleticism in a 3 to 5 foot Hawaiian scale day out at Sandy Beach. That's death defying, and guys are laying on their backs and just having these ledges roll over them. And if they want to call it 3 to 5, that's how I'm going to call it, because we want to respect the locals, the most hardcore guys for every shoreline. And in Hawaii, compared to most of the world, we tend to, it sounds conservative, but it is what they call, and what Pat has called and scientifically validated, is called you call it the surfer scale, right, Pat?
Hawaii scale, I refer to it.
Hawaii scale. Okay. Hawaii scale.
I don't call it Hawaiian. It's not the Hawaiian culture. It's
right.
Hawaii scale.
Yeah. So local scale, we can refer to it local scale, local surfer scale. The guys know. And we've been very, there's been a lot of, the National Weather Service has tried to, and Pat puts it out there, the face scale. And then there's the swell, which approximates the local scale, or closer to it at least. So, a head high wave we'd call 3 feet, but if you actually take a yardstick, 3 feet's like up to your waist. So there is a little bit of, it does lend itself to a little bit of confusion, but to the locals who've been at it and who have a lot of experience, are out there daily, they know what they understand. And what you were talking about, David, for this, so the TV stations, we do the surf reports for them, and they requested face scale. So one station, for example, channel 2, I do local scale, but channel 4, I do face scale. Yep. So it's whatever they want. And then actually at surfnewsnetwork.com, I post both. And seems to get the job done.
So is there a formula that could go back and forth between the scales?
Well, it's tricky. I mean, it's roughly 50%, but what we'll say is there's like, you can call away 5 feet and you can either give it, like we tend to think that, or put out there that it's about 9 feet in the face, 6 feet double overhead, 10 foot faces. A triple overhead would be 15-foot faces, but you could say 16. The upper range and the variation, it's not exact. And Pat, you can jump in here, anytime. So it's not exactly 50-50 for the local scale, especially when it gets big. In the 80s, I used to ride Waimea, and when it was 20 feet, it usually meant about 35-foot faces. So, and that's what all the surfers would agree on, about a little less than half. I don't know, is there an exact formula on that, Pat?
Well, the main point to keep in mind is that wave estimates by the human eye are coarse resolution. So ballparking it is fine. Roughly half, fine. Because you got to consider the fact that waves are instantaneous. They come and go quickly. And on a given wave front, you can have different sizes along the front, the peak versus the shoulder. And then you can have waves breaking at different parts of the same reef, but some areas jack up a little more. So it's just coarse resolution, and just ballparking it is fine.
Yeah. If I were to put a number on it, like the scale that we use, it's roughly like a 6-foot wave. Some people would claim 12-foot faces. We go ahead with 10. So whatever percentage that is, like, maybe 20% off of that, maybe a quarter. So it's not much. It roughly, like Pat said, 50%, but not exactly.
Well, it's just a ballpark is what the point is. It's just,
yeah,
we don't have a precise measurement. It's just,
what I use a lot of times is where the surfers are sitting. You just look out. I don't even need to see a set sometimes. I can tell, like, say, at Ala Moana Bowls, it can't be much more than this because of where the guys are sitting. Or if they're sitting further over towards the buoys, oh, wait a minute, there might be a 20-minute flat spell from these distant storms coming that are producing our south-southwest swells. But even 20 or 30 minutes, then all of a sudden, it's just game on with sets stacking in over towards the buoys. And you can tell a lot about us without even seeing a wave, approximately how big it is. Again, that's that intuition from just overall years of experience, what kind of swell we're dealing with. And I always correlate it with the buoys, the observations on the cameras, and we have our own guys that stand at the beach. But like Pat said, it is definitely coarse resolution. So everybody has just a slight tweak of their scale.
So when you make your daily reports, what sort of resources do you use?
Well, definitely Pat, definitely Surfline, definitely our observations. Wave Watch 3. We just come up with a smorgasbord or a composite score. But you always got to look at it in the morning and eyeball it and just measure it up against the buoys and then make a claim. And even so, that can change. There are some swells that might drop a little quicker than you thought. Some swells might get a little bit bigger than you thought, and then you just tweak it. But that's why observations are so important. You just tweak it as you go. Like this current swell is dropping. I was just out there this morning. Pat was out earlier. He had some waves up towards 9 feet in the face, Pat? You were saying?
I would say 9 plus or minus 1 on the biggest sets.
And when I was out a few hours later with the swell fading slowly, it would breathe, and then it would hold its breath, and it would breathe again. But I definitely saw some 8-foot faces out there, just a little bit less, maybe a little less consistency. And so, but we don't talk about the spots that Pat and I surfed. We talk about Sunset Beach, Rockies, Pipeline, Gas Chambers. There's certain main spots all the way down to Haleiwa, Chuns, Lania, Kea. We don't talk about Mokulea. We don't talk about where Pat was this morning. We don't talk about where I surfed.
Well, is it tricky forecasting for so many spots at once?
Yes, that's why, if somebody says, oh, hey man, the report was off, I was going, well, what spot are you talking about and what time? Especially as we get into the winter months, there's a lot of stuff. We got some sizable warning level swells coming. And so it'll be very interesting. One of the toughest places to correlate is Makaha. You could look at the North Shore, you're thinking, wow, it's 10 to 15 feet, high surf warnings posted, 25-foot faces, outer reefs cracking. You're thinking Makaha's got to be 8, maybe 10 feet, right, Pat? Maybe a third off. Sometimes it gets shadowed by Ni'ihau and Kauai, and sometimes it just for some reason doesn't bend in there. It might not be in there in the morning. While the North Shore is 15 feet, Makaha, I've literally seen it be 6 feet. You're going, how is that even possible? It's like one ocean. It's not that far away. What is going on here? So it has confounded us many, many times out of Makaha. And then by noon, it's fully filled in and it's on. It's 10 feet, which is about the proper correlation between the North Shore and the West Shore, about a third to half.
Okay, for our viewers in the South Pacific, Gary's talking about surf break that's on the west side of Oahu, on the west side of the island. So the waves the northwest swells wrap around, but estimating how much they're going to wrap around is very tricky. It's not.
Yeah. It's actually, I was going to say before I lose my train of thought, that a northwest swell is not really wrap. There's a portion of the swell is wrap, but a portion of it's pretty good. A pretty, it gets in there. What is the shadow, Pat? Was it
from the top of Honolulu or right the Kilauea Lighthouse on Kauai?
Yeah.
The Waianae Harbor, I believe offhand, is 315 degrees.
Okay.
So you need a little bit more north of northwest for that magic spot for it. And then in that case, it's not wrapping, it's coming directly in. But the issue is if you look at a map, you see that the west side of Oahu runs northwest to southeast. So it's not really facing into it the way you look at the North Shore, and it looks like a catcher's mitt is facing right into that northwest. So it's coming straight on. So that's an aspect of refraction. When waves are coming at an angle to the breaker zone, then you lose somewhat of the energy as it bends into the breaker zone.
Yeah. So it's just an interesting, it's one of those spots that, observations are key, and it can change within a given day, especially when there's a big event. And this swell that's on the way, David, and you know about it, and Pat, I'm sure you know about it too, is, I don't know if you'd make a claim on it yet, but it seems like Wave Watch 3 really wants this thing to be warning levels. Would you agree on that, Pat? Would you make a claim on that yet?
I don't know which one you're talking about.
Oh boy, I'd have to look at my website. I'm on here, but it's in November, and it's there's a big swell coming about the nearby low pressure. Oh my God, and there's a huge typhoon coming
Well,
as
that's,
well.
in the category of, there's like 3 phases of surf forecasting. Phase 1, which is the near term, you see it on the buoy, you got high confidence. Phase 2 is when the systems unfold, and you got satellites and you can validate what happened in the ocean, you know what the seas are generated. And then phase 3 is out into the forecast. And so that goes way out. And until the system unfolds, your level of confidence decreases as you go from the near term to the long term. So what you're talking about now is the long term. So your confidence has gone way down.
Yeah. Low probability or a big question mark. You know, I call it model fantasy, but I do like to, you know, for me, again, people that come to my website, they I think they would prefer at least a heads up, and even at the expense of maybe being a little bit of a disappointment. Like, there is a chance, you know, of a really big swell happening, but then again, I've seen it fall apart. And so how we word it in the big picture, you had it in a big picture, right, Dave? David, you did
Yep.
didn't you have
Yeah,
in the big?
if my memory serves me correctly, I think I put up to 15 foot. So that would be warning level by
Yeah,
WS standards.
yeah. Well, let's hope so. It'll be by far, you know, the biggest event that we've seen, and so it's definitely signs of winter. But it's really neat to see that plenty south swells still coming our way well into November. How rare is that, Pat?
No, that's not too uncommon. We can, it is the end of the season. But if you get anything after November 15th, then it starts to get real rare. But all the way up into the first 1 or 2 weeks of November is not too uncommon. I'd say 1 out of every 3 or 4 years, you're going to get decent, you know, head high swell.
Okay.
I mean, we had one last year, right on Veterans Day weekend, that was overhead.
And where'd you surf? Can't tell me. Can't tell us.
Okay. Gary, you have any final comments?
You know, surf forecasting is an art form. It's art and science. It's, you know, it's a bit of personal opinion, but it's also, there's an objectivity to it. And the main thing is, you know, you can put out information from a knowledge point of view, but we put it out there, you know, and like Pat is a lot of it's about safety, and whereas ours is, you know, very recreational oriented. So there are numbers for it. And so anybody looking to, you know, do it in your area, you know, depending on your population, you know, you can actually, you know, turn it into a business and put this information out on all platforms and have fun, maybe, you know, driving your own marketing business. There is definitely some money to be made in it if you want to give it a shot.
Yeah, and I think that's actually a good point for our students, because they're typically, hold on a second.
Sure. Got to run to the restroom?
No, there's a lot of yard work going on today.
Oh, okay.
Typically where our students are, and you know, the reason I developed some skills in forecasting myself was because I was in Guam, where there is no Surf News Network, there is no Pat Caldwell site. You're basically on your own. But that actually is an opportunity to really learn how to
Yes.
look at the raw data and put things together yourself. So it's kind of an opportunity that I think a lot of the guys out there in the South Pacific have.
Yeah.
Or in Micronesia.
Yes, you know, it's not necessarily a get rich thing, but if you can do something that has meaning, and it has something to do with your passion, you know, then by all means, I don't know how many people are actually getting out there, but you could do dive reports, free diver, snorkeling, surfing, sailing, and you put it all together. Somebody's probably, you know, you broaden your market by, you know, broadening the news feature, and try to do it for your local networks. Try to do it for your, I don't know, does Guam have radio stations? Just kidding. I'm sure they do.
They'll have radio
you know, you know, and online and come up with your own little localized Guam surf report, there could be a lot of bars and restaurants and dive shops maybe that would love to sponsor something like that.
Yeah, and I'm glad you brought that up because your site, it's mostly oriented towards surfing, but you also have a sailing report and you have a diving report and discuss like water clarity. And all these things depend on the weather and the surf. So
yeah, and even the tide, you know, one of the things that we've been having recently that I don't remember them having in the past, Pat, maybe you can tell me if I'm wrong, but we've been having a lot of nuisance coastal flooding as an advisory. And out here now where I live, I see it firsthand. The waves, even when the sea levels are not a half a foot higher than average, even on a 2 foot high tide, those waves come in and they bash into the seawalls of these really nice houses. And I have to make a run for my exit in between sets because it can knock me over. So when there's nuisance coastal flooding on these high astronomical tides and then higher than average sea levels, it really can make a difference. So that would be something that they could do that's influences fishing, just simply going to the beach and hanging out, diving, and then of course high tides affect surfing as well. I don't know, you would know more than me, David, about how Guam is affected. I hear it's pretty shallow down there, so probably a higher tide is actually what you want over there. And over here, typically it's just the opposite.
right, from a surfing perspective, yeah, high tides are good out there in the deep tropics.
Yeah, like Samoa.
Yeah, Samoa too.
Tahiti. Okay.
Great, thank you, Gary.
Yeah, my pleasure. Thank you.
So with that, I'll turn it over now to Pat. Pat, do you want to screen share?
Sure, I'll do the share screen. And so you see my screen now?
Yes.
Here I could start off
Nice.
out to the Moku Manu Islands off the east side of Oahu last Saturday. The motivation was we had very, very low swell conditions from around the compass, about as low as it goes. And the trades have been gone for quite a while. There was imminent rising short period waves later Saturday, but Saturday morning was at a minimum. So we paddled from Kailua Beach out there. It was like 2.5 hours on kayaks to paddle out there. And yeah, it was amazing. And so there's an example of the anti-surf forecast. You want it as low as it goes.
Gorgeous day. Gorgeous, clear.
It was. We got, after all those rainy, cloudy days we had, there was a huge amount of rain in the morning right off of Barber's, but it backed off and dissipated. So we got lucky. And but what I want to talk today is a little bit of a overlap of what David already mentioned you all have done. But I just want to point out that here is the marine products page, the Hawaii Honolulu Forecast Office, the National Weather Service in Honolulu. And this is where I do what's called the collaborative surf forecast, which is, you've seen before, with the table and includes a discussion. And the primary marine desk does this. It's now the statewide surf forecast. It used to always be called Oahu surf forecast until just within like the last month. And so they have a new format. And so my job as a forecaster is to collaborate with the other forecasters, because the table I include has winds and that sort of thing. So when the Weather Service puts out a package, you want to be consistent. So everybody's saying the same thing. And you can see from Monday's forecast for this week, when we had that prediction of the low center right north of us, and well, what will the winds be, southwest or west or northwest or north? I chickened out and I just put variable right on through. So that's what you do. Refer to the latest updates, because there's situations when the weather pattern is close that you're better off just saying you don't know, and just get the latest update. And but the main thing I wanted to talk about here is taking you to this page that you can find, the marine products page of the Honolulu National Weather Service. And if you drop down here, you see some fun things. One of them is what I put together is the Wahoo surf climatology. And so you can go here and see all the different things. And here's some notes about where the visual surf observations come from, with kudos to Gary's Surf News Network and lifeguards. And so I put together some climatologies. And just as a quick reference, here's a quick link right up here if you just want to look at some of the basic climatological products. Here's a fun one here. So what this is we have data that start in August 1st, 1968 and go up to the present. And every single day there's a single value that's representing the time of day with the biggest breakers, and it's representing whatever the upper end of the range is, the way the surfers give it. So if the surfers say it's 4 to 6 in the morning and it's 6 to 8 in the afternoon, one value of 8 went into the database. So there's one value per day. And what you're seeing right here is the whole calendar year along the x-axis. It goes from August with January in the middle. So you can see the annual cycle on the North Shore. And so for any given day, let's take a look at December 4th. So on December 4th, we have all days. We have what was the maximum, this one up here where it says maximum, what was the biggest day that ever happened on a December 4th? And here it is right here. And I've converted it from Hawaii scale, with the way it went into the database is 40 Hawaii scale. And I put it in there in 80. So it was 70, was it 90? Who cares? I mean, it's a ballpark. It was huge. But anyhow, that's what you're looking at here is this thin line is the largest that there's ever been on any given single calendar day. And what this thick black line is a 90-day running mean. So it smooths it all out. So you can see what's your typical average at this time of year. So if you go into the month of January, what's your typical maximum? So your biggest days that you get in the month of January, you're talking somewhere around 45 on the face. So those are your typical big day maximums. And then this next set of curves down here is your average. So for instance, on December 4th, what is the average over all roughly 50 years from 1968? This was made in 2016. What was the average over all those December 4ths? And you can see right here, it's running around 15 feet on the face. So that's your typical high surf advisory, but based on conditions with the West Weather Service. So it's near the high surf criteria, starting in the month of December and then going almost through the end of February. So pretty much once you get into December, the winter months on the North Shores of the Hawaiian Islands, more times than not, you've got high surf. So it's a lot of big surf. That's why it's so important, because of the safety aspects, protection of life and property. But I also like to point out that the huge variability, this bottom line here is the minimum. What's the smallest that has ever occurred on a given day on the calendar day? So here's your December 4th. What was the smallest day that ever occurred? Well, there was one down here that this little line here is showing it's somewhere probably around 5 feet on the face. So going into the month of December, about 5 feet on the face is about as low as it's going to go. You're not going to see absolute flat up there in the month of December. There's still a little bit of, in the South Shore, we call it the background. There's almost something out there at Ala Moana and Kaisers every day. I mean, you don't see it go flat. So this is kind of like your background wintertime that you're going to get somewhere around 4 or 5 feet as on the smallest of small days. So this is what we refer to as the annual cycle, how it changes, wanes and waxes and wanes with the season. And we can look at another product. This is an interesting one. is the directionality is interesting. And this you can actually just tie right into the meteorological phenomena, because early in the season, your jet stream tends to be further north, and it's not quite as strong, and so it'll tend to want to cut off these big old upper level gyres, sort of like we had a week ago. We had a gyre cut off near the islands, and in the models by tomorrow, we have a new low pressure gyre cutting off just north of the islands. So that's more of the earlier in the season when a lot of those things happen. And what you end up getting, if you can see this color code here, where there's this custard, mustard looking yellow,
Yeah.
and the red, those are more north direction. So you see, as we go into the start of the season, you tend to get more north direction, and then the north direction kind of falls off. And then going into the spring again, you tend to get north again. And that's related to the migration and the strength of the jet stream. And on contrary, you can see for your west northwest energy, that's more centered right on the midwinter, when the jet stream's further south, and you get that Tokyo Express, the jet stream comes off of Tokyo and just charges eastward with embedded short waves and surface low pressure features that typically get the storm force. So we get our bulk of west through northwest energy it's more dominant during the winter months. So that's an interesting point to point out. You get more northerly in the earlier season, and you get more westerly in midwinter, just as a climatological aspect.
Yeah,
and,
very
so that's
cool.
the main two things I wanted to talk about there. But then I wanted to move on to another one of the links that you can find right off the marine products page of the National Weather Service. It's right here. It's sort of what Gary was talking about just a moment ago. It says, how do you define what the surf heights are for a given coast when you have so much variation? And when you're up at the North Shore, you say, for instance, I'll go right there to the link. And here's an aerial shot looking down, and here's chuns and piddlies, and here's jockos and right over here at Holton's. And what you're seeing is that where the seafloor is shallow, you're going to have the waves focus. And then in between where it's deeper, you have a wave divergence and less surf. So all along the coast of Hawaii, we tend to have irregular seafloor shape. And therefore, you get these zones where it focuses energy and zones where the energy diverges away and there's almost nothing. So that's the spatial aspect. From place to place. And then there's another aspect, which is moment to moment. If you're sitting just at one particular lineup here at Chun's, you notice that it's not just a conveyor belt with every wave coming in exactly the same size. You get a range of sizes, and you tend to get spells where there's hardly anything. And then if you're caught inside and trying to paddle out, you get spells where the waves just won't stop. It's just one of those Murphy Law phenomena. And so that's what I'm going to kind of go into. And by doing that, I'm just going to bring up some of the basics of wave science. So here's your definition from the textbook. Your height is the trough to crest, and your length is trough to trough or crest to crest. And that's the distance, or you can call it wave period, which is one of the critical parameters that we get off the buoys, because it gives the dominant wave period. And that's essential for surfers. They prefer to see a long wave period that represents swell. And so those are your basic characteristics. And just like in the animal world, you have a word like dogs, and within the dog world, you can have labradoodles to chihuahuas to dachshunds. In the world of surf, we have waves, but these waves have different names, different types. And the seas here, this would be your labradoodles right here. They're all mixed up. This is where the waves are being generated. And once they form and they start to travel away from the generation zone, they spread out. It's called dispersion, because the longer the wavelength, the faster it travels. So whatever those long wave periods or wavelengths in the generating zone race out ahead. And because they do that, they disperse, they tend to group in large areas, surface areas of the ocean, of similar wave period. And when it does that, it gets a very orderly line to it, a very regular looking pattern. And then finally, we use the term surf or breaker to mean what happens once the wave energy feels the bottom and trips up. And it's really critical in the world of surf forecasting to focus on the seas. And if you have a buoy out there, you're sitting under, say, a 45-mile-an-hour severe gale that's been blowing over 900 nautical miles for a day and a half, you're going to get fully developed seas up where around 35 feet or so. And if you have a buoy out there, you're going to see energy from the shortest wave periods, where the chop, all the way up to the longest. And the way that the oceanographers like to communicate with one another to describe how this energy is spread along wave periods. Here's the shorter wave periods off to the right of this lower panel where it says spectrum. It's called a spectrum. It's the name of the science tool that's used. And you're seeing the where the peak of the energy, this is the y-axis is energy, where you see the most energy is where we would refer to dominant. But if you look on the buoy data, let me pull that up real quick here, because it's always good to relate to what you see at a buoy. So here's buoy 1. Let me get the latest. See if I got to surf in the morning and update it. So we have the significant wave height, which is the combined seas and swells of 6 feet. But the swell height, that would only be the energy from roughly 10 seconds all the way up. The long wave periods, it integrates across all that energy. And in this particular case, it's 5.9 feet. So there's not much wind waves going on. You see the wind waves are 2 feet. So, and when you get to what's called the, actually, they didn't actually have it here. They have the swell period. Oh, maybe it's up top. Oh, I don't see it there. I was looking for the dominant wave period. APD. Because normally they give a symbol T with a little subscript P. When what they're referring to is peak period. For some reason, I don't see that here. But anyhow, the important point, let me get back to my diagram, is that seas are composed of waves from the shortest all the way to the longest, and these long ones take time to grow. You need a long fetch with strong winds over a long period of time. And if you have a buoy out there under those seas, you would get something like this. And what's critical at this particular moment in time is once those seas are generated, in order to calculate when the waves will arrive on your shore, you use the dominant wave period. This is when the bulk of the energy this would be your peak of the swell episode on your shore would be related to the dominant energy. But you can see there's also some energy all the way that's lower, but all the way up to 20 to 25 seconds. So when you get those massive wintertime gyres north of Hawaii with storm force winds over vast areas, you get long period swell generated. And though that energy may not be as high, but that's what's going to arrive first. So if you want to know when will the forerunners, the first little bit of energy, start to tickle in to your shore, sometimes it's more than a tickle, it's more like a slap on the face. But anyhow, so you use this dominant wave period, and that's what you can use as because the speed of the groups of waves, as you mentioned, there's two types of speeds. There's what's called phase speed, and that's what the individual wave will move at. And there's the group speed, and that's what the batch of swell, the consecutive dozen of them, move at. There's that theory that the first wave in that group has to agitate the flat surface in front of it, and it gets lost. And it's kind of like a garden hose. Suddenly a new one pops up in the back. So you still have 10 waves moving along, but you're constantly losing one in the front, and you're gaining one in the back. And the net result is that it's about half. So amen that it's just about half instead of 7/8 or 32/64 or something, that we really have to apply some major thinking to figure it out. But so it's only half, so it makes it simple. And so anyhow, that's the important point. So if anything you learn in wave forecasting that you have down is to know your wave spectrum, to know about that you have your dominant energy and you want to calculate when the peak of the event is going to hit your shore. It's going to be how far it has to travel. And that speed is purely a function of the wave period. So it's 17 seconds is always the same. It's about 600 nautical miles a day. 20 seconds is always the same. It's about 700 nautical miles a day. 14 seconds is always the same. It's about 500 nautical miles a day. So there's these kind of things that are, and it's good to memorize all these little things that you pick the categories where it's simple. And then when you look at the charts, you can quickly say, okay, that swell will be here by dawn Friday. And so let me move on now to some of the other aspects. And let me move on down. So this is kind of some general aspects that was already been mentioned. The main point about the transformation of swell, deep water swell into a breaker is that there's two aspects, physical aspects, that can change the height of the breaker. And the one is the fact that it gets shallow, and that's what's called shoaling. So that can add size to the breaker. So you can just think of your typical beach break where the seafloor contours are all parallel with the shore. Yeah, so right off the coast of Long Beach in California, it's a big closeouts because there's nothing out there to focus the energy. It's just going to come in and close out. So you just have a beach break. And so, but the fact that it gets shallower means that whatever the swell was offshore is going to be bigger when it breaks, just from the fact that the friction of the bottom. I'm sure you've already discussed the fact that the passing of each wave sets in motion these little circles underneath. And the reason it's called a shallow water wave is because those circles reach all the way to the seafloor, and they're grabbing that seafloor and it's slowing it down. And so that's one important fact of why the waves get bigger when they come out of the deep water and break is because it gets more shallow. And the second factor, more specifically for Hawaii, is that when you have irregular shaped shorelines and you have the seafloor is also irregularly shaped, that you have areas where the waves can focus on. And it's still the same principle taking place where waves slow down when they feel the bottom due to friction. So you can see right here at Sunset Beach, this first wave that was further out here, it started to feel that hump. There's that hill on the seafloor off the Sunset, and it starts to slow down right in front of that hill or right over that hill. But on either side, it's deeper, so it bends, and you see that bow there, the classic Tavarua bow. And that's because the center of this wave face is in shallower water, and the shoulder of the wave face is in deeper water. So the deeper water is racing on ahead. But the net effect of that is that you're getting this bending motion. So this is your wavefront from left to right. And the areas in the deeper water where it's bending actually send energy towards the front. So there's actually a mass transport of water. There's a water volume transport that takes place along that wavefront. And it's bringing that wave in. Just think of a picture of Jaws over on Maui when it breaks in that big giant triangle, because that deep water on either side and that mass convergence, it's water convergence that's moving inward towards the shallow zone. So that's what we refer to as refraction. So it's the shoaling and refraction that make the breakers much bigger than the offshore waves. And let me see. I was looking for, so here's your an example of a seafloor in Hawaii, and we're back to Chun's again. Here's Chun's Reef right here. Jocko's, not much surf on this day, but the important point is that you can see all the ancient riverbeds and lava flows and sandbars and coral reef growth, and then what you end up with is a complex amount of differences in seafloor depth. along this area. And all the places where you have bumps on the seafloor, hills on the seafloor, are basically surf spots. So here we got leftovers, right overs. I forgot it. Kiniwashis, I forgot the name of that one, but Piddlies. But anyway, there's on the north shore of Oahu, you just have spot after spot after spot, because every one of these little bumps on the seafloor allows that bending motion. And that's what surfers want. They want the bending motion, because what it does, it means that the reason that it is bending is that there's deeper water on the side, and that's where you can have safe access to paddle out. So more times than not in Hawaii, after you've ridden a wave, you get to paddle out in a quasi channel. So it's less punishment than it's, say, if you're riding at leftovers and you wipe out and you're right directly in front of the waves and you try to paddle straight out, you're going to get hammered. And so let me move on a little bit here. And so that's your basic. So that kind of explains your typical aspects of spatial variability. And the main reason is the complex nature of the seafloor. And then your waves in time. And so the temporal variability is also something that you can measure out at the buoys. For instance, if we go out here, and let's just look at this swell height, and maybe it'll go back a couple days here. So there you go. So you can see here this, you can see this big peak where the swell out at buoy 1 got to 10 feet. And what you notice here is this jitter up and down. And the important point here is that waves are not linear. It's not like a steady state ocean where every wave is the exact same height and it's moving along, you know, like you draw on your notebooks in high school, where it's just like nonstop perfection, always the same size. In reality, you get a lot of what the oceanographers would refer to as envelopes. And just as you typically, a surfer knows when a set of waves comes in, the bigger ones they want to catch, they're usually the same size, and you get anywhere between 1 to as many as 5 on average. I mean, maybe 3 would be a good average number. Sometimes you get back-to-back sets, so it just doesn't stop. But on average, you tend to get 2 or 3 really good ones. So you sit out there and wait. But the spacing between those waves of a given size, surfers know, is somewhere 5 to 10 minutes. But also, these points right here are hour to hour. So you get a lot of hour to hour variability, or the wave energy is just not a constant field. And it's one of the aspects, the daunting task of a surf forecaster is to explain to the public why it's not the same all the time everywhere. It's sort of like today's rain forecast. There's flash flood advisories.
Yeah.
There's no rain. So will not rain here, but for the person that was underneath that thunder cell, they would say a lot different. So it is just, nature is complex, and you can't just generalize. And an important point about waves is that there's a lot of variability from set to set, and there's also variability over 30 minutes to, say, 2 hours. Surfers know, we call them the shower sets. You were out there and there was hardly anything coming in. You get up to the shower and you're looking out and you go, man, look at those waves. You know, so it's just one of those phenomena that sometimes you get lucky and you have to score those, the oceanographer would call an active envelope. When you score those active envelopes, man, you're happy. You get 20, 30 minute spells and there's like a ton of waves. Then you get maybe 45 minutes and it's just like much more sleepy. You got to kind of shift your entire lineup in, because waves always break in water of similar depth. So the bigger the waves, the further offshore they break. So you're constantly having to adjust where your lineup is based on the pattern of waves. And that's always that tricky thing. If you're the guy like me with the SUP and doesn't like to get caught inside, I like to sit way out there, that it can get real boring when the low envelopes start to come in and everyone's kind of shifted in, and then you finally give up and paddle in there, or at least to the edge of it. So if a big set comes, you can get away. But that's one of the important take-home points, is that in time, waves have huge amount of variability, as depicted here by this jitter up and down of the swell height. And so I'll talk a little bit more about that later. And that was the main point I wanted to talk about there. And now I just wanted to go and give an example. It's always fun to talk about a historic case. And let me find my directory. We had a really big swell back in the third week of March in 2020. And Tropical Cyclone Gretel, I don't know if Hansel came next. No, he would have been before. He would come next. Hansen would have came after. But anyway, Gretel gave the goodies. It formed north of New Zealand. And the important point is, we'll watch the storm surf seas. It kind of tells you where the high seas were. You can see that on the 16th, actually in Hawaii would have been the 15th. But anyway, this was Gretel up here north of New Zealand. And oops, I gotta change my size so I can see my arrow to go forward. And so you walk it forward, there's Monday, here we are into Tuesday, starting to get some 30-foot seas. They really weren't aiming too well at Hawaii until Tuesday afternoon. Well, here they're still aiming more straight north. They're not quite aiming at Hawaii yet. But going into Wednesday morning, bingo, here we go. We got some 30-foot seas and they're starting to aim directly. Hawaii is at 160, so Hawaii would sit right up about here. And here it is. It's got some, you got some validation from the Jason. There's a 25 right there. So seas are up around 30 here in the maximum. And this is Wednesday morning, the 18th. And Wednesday afternoon, it got even bigger, getting up to some 40-foot seas. And then into Thursday morning. And another aspect that we can look at is the ASCAT. What we like to do once a weather pattern unfolds, we've been watching the models. Are the models right? We need to know if what happens in nature is really what the human brain conjured it up to think it would do. So it's not always true. Sometimes they're weaker, sometimes they're stronger. And in this particular case, you can see this was on the 17th, so that would have been that Tuesday, and the system was tracking towards the southeast. But you can see a big area of severe gales. They're starting to nose towards in the Hawaii direction, though mostly missing Hawaii to the west. But well aimed at American Samoa, I must add. And then here's another ASCAT. You can see that the center of the system has now moved down near 40 south. So it's kind of moving away, but then it starts to slow down. You still have a big batch of severe gales and a larger batch of these brown or gales. And then there's the near gales. And the head of the fetch is going right up into the subtropics. So this is on the order of 3,000 nautical miles away. Our typical sources from down under happen southeast of New Zealand on the order of 5,000 nautical miles away. So this is easily over 1,000 nautical miles closer to Hawaii than most south swell sources. And waves lose size as they travel. So the closer to Hawaii, the bigger it's going to be in Hawaii. And here was another one going into the 18th and then into the 19th. There was still some severe gales. In that point, actually, the last 2 days it occluded down there. And so it sat in the same place. And that's always good because you get a longer duration. And so anyway, back to the seas. Well, actually, the next thing I want to point out is that, so these waves are generated. And let's look at the spectral density. And before I tell you what the spectral density is, let me show you where you find it on a web page. For instance, I can even go to, here's the CDIP Pongo in the NDBC style. So you get the same kind of look as buoy 1. So here's the American Samoa buoy. And if you want to see what the spectral energy is, here's where they give you the swell height. So they're integrating all the energy 10 seconds or longer, and they're showing a 3.3 with a dominant swell period of 10 seconds. So it's still on the short side. But what you need to do, if you want to find the actual nuts and bolts to a surf forecast, is get down to where it says real data. And you go to the real-time raw spectral wave data. There's a description over there to help you out, because hold your horses here. It's Halloween, time to get scared. So what you do here is you go up to view, page style, no page style, and then now they all line up. So here's each hour, here's your hours right here. So this was 02Z or 4 p.m. Locals. Already after 4? I'll be darned. I guess I'm not surfing this afternoon. Anyway, here's your 02Z, and here's your spectral wave energy. And what you have to do is take any of these values within parentheses and go 1 over that value. So 1 over 0.05 is 20 seconds. So here's your 20-second energy. Here's your 15-second, and you get on down. And so you see there's not much long period energy, but here when you get down to 10 seconds, which is right in here, you can see a lot of energy. So that swell that's going through Samoa right now is basically a wind swell. So anyway, I wanted to show you where I got the data because I'm going to give you this plot right here. And so here's the what was generated by that the remnant of Tropical Cyclone Gretel last March. And what I'm showing you right here is both the blue is the American Samoa buoy and the red is the Barbers Point. And I think I saved a map. So this little point right here is American Samoa, and here's Hawaii. So on this graph, I have the blue will be your American Samoa and the red will be your Barbers Point. And it's roughly like 190 degree on the Great Circle from American Samoa to Hawaii, 2,100 nautical miles. So remember I mentioned 20-second energy travels 700 nautical miles a day. So it's 3-day travel for your 20-second energy. And so these plots I'm showing you, each one is for a given wave period band. I have the 16-second here at the top, and on the bottom axis is hours. And I went back in time. 120 hours is 5 days. So I had to go back 5 days. So here's like about 7 days back, because here's the 17-second energy coming into American Samoa. And then here's that same swell coming into Hawaii 5 days or 3 days later, roughly. And so here's your 17-second energy, the 18, the 22nd right here, all the way down to 22. So you can see there was a lot of energy all the way up in the 22. Well, actually, here's the units. They weren't that really, the amount of energy in 22 seconds wasn't that much. 20 seconds, well, there's a little bit. It's on the units of 2.5. But when you got here to 18 seconds and you got to 17 seconds, there was a bunch of energy. When I saw this, I had never, ever seen the Pongo Pongo buoy so energetic in the 17 and 18 second band. I mean, I was like, whoa, that is going to be big. And you can see the direction, these little V shapes I have right here, those are giving the direction. And back there on the wave page, I better take it out of the, basically, if you go back, you can get the direction too. It's called Alpha 1 down there in the real-time data. So the real-time raw spectral wave Alpha 1 data, that Alpha 1 is code. We don't want all the surfers to figure this out. That means the direction. So we got it coded. Anyhow, so that you're getting the wave spectral density energy and the wave direction associated. Each one of these values is a 1 hour value. And you can see where it's coming out of the south-southeast. And that's what it kind of looked like, because the strong fetch in the earlier stages was pointing a little bit west of Hawaii. And but what's interesting is seeing, here's this red you're seeing right here just happens to coincide with an earlier event we had in Hawaii. So we had 2 events at Barbers Point in March. And so this energy would have been way over here to the left when it passed under the American Samoa buoy. But it's just a coincidence that on this particular day, which was around the 19th of March, we had waves in Hawaii, but there was also swell of similar wave period going through American Samoa. But what you really need to concentrate on is how the blue energy rolled underneath the American Samoa buoy, and then roughly 3 to 4 days later, here it is in Hawaii, as measured by the Barbers Point buoy. And you can see the Barbers Point is showing what it should, roughly from 190 degrees is the angle. And you can also see the jitter, the hour to hour up and down. And so that's your 17 to 22 seconds. So that's your extra long wave period. Let me go back to, a second, I gotta find my other one. Oh, here it is. So here's the 13 to 17 seconds energy. And this is really fascinating because one of the aspects of wave science is that the longer the wave period, the more it holds its size with travel distance. And that's because the shorter the wave period, you have a much sharper angular spreading. And the more angular spreading, the greater loss in time, with time. And so what's interesting here, here's your 17. It went through the blue was American Samoa, the red was Barbers Point. It was still pretty darn energetic. This peak energy of 20 is huge. And then here's the 15, and he had a lot of energy. 15, he had some in 15 here. So, but here's the 14 second. Look, you had this one spike to 60 units of 60 at America Samoa, and we barely got in Hawaii up to 10, but mostly between 5 and 10. But what this is telling you is that the shorter the wave period, the more it's going to lose swell energy with travel distance. So if you want to see the Mondo swells that make the biggest waves on the south shore of Oahu, which I will now go to because we all love looking at pictures of surf, is in order to get this kind of wave, you need, and it from the austral winter, their wintertime, our summer, from that source, not a hurricane. That's a totally different story. But you know, we can look at some of these waves. So this was Tuesday, March 24th, the big day. And for some reason that thing's not going up. Anyway, I'll just kind of walk through it. I don't know why my size thing doesn't want to. Here we go. So you can see the person right there, and you can see the wave. That this wasn't your typical day at Ala Moana. This is kind of on the upper end of as big as it gets here at Ala Moana. And I'll step through. These are just screen grabs that day. Yeah, there's a really big one. Here's off of the public. Ooh. That's castles breaking out here. There's another one. Here's Publix. These guys about to get caught inside. So Castles was breaking out there. And here's a sequence. This was one of the biggest ones. I looked at the spectral density energy at Barbers. I saw the peak in the morning between 7 to 8. So then I went back and I got the rewind from the Surfline cams. You can rewind it. Luckily, I was there within a day or two of it happening. And I studied through the rewind, and I found this between 6 and 7 in the morning. And the time's all messed up here. I think it's something to do with California time, or I don't know what was going on. But anyhow, so this is a sequence right here. Well, I'll step through it. There's your crowd. The buoy's gone. The red buoy got ripped out the night before, the navigational buoy out the entrance of the Alawai Canal. And there's the green buoy. The green buoy is the buoy on the right, you know, to your right side as you go seaward. The red buoy is long gone. And so this was a really, really big episode. Here comes another one. And so this is pretty much about as big as it gets on the South Shores. So that takes me to the end. So that just in summary, the important point is to understand the temporal variability, the fact that you get a lot of jitter up and down from hour to hour. So if you're out there and it's not real good, just go in and hang out a little bit, play some ukulele and watch it, and never know, it just may jump right up. So there's a huge amount of variability from hour to hour. And you can look at if you're on the South Shore of Oahu, you can look at buoys 2, 3, and 4. Oh yeah, I forgot I had those in my, here's buoys 2, 3, and 4. So I have these color coded. This is your longest period energy, 17, 19, 21. And this is as it rolled under the southern NOAA buoys. We're roughly 200 miles south of Oahu. The buoy 4 is southeast of Hilo. Buoy 2 straight south of Oahu, roughly. Buoy 3 It's southwest of Oahu, more south of Kauai. And you can see how this energy went in. And I got these threshold lines here to know, based on historical databases, when did we see a 10-foot face on the bigger sets with this type of wave energy in the 19-second band. So this yellow line means that, whoa, we're going to be above 10-foot face. And this orange line means historically there was energy levels that were up near 15-foot face. And it doesn't happen often on the South Shores, but you can see what's interesting here. Remember that the green here is buoy 3, and that's southwest of Kauai. The buoy 2 one is the one that's more the direct representative of what's going to hit Oahu under the straight south, near straight south direction. And what this is pointing out is the fact that, and this happens all the time, usually it's the other way around, is that the big swells come rolling under New Zealand, they aim at the Americas, and buoy 3 is much smaller than buoy 4, which is southeast of Hilo, because the swell misses Hawaii to the east. But in this particular case, because the unique nature of the reforming of tropical cyclone Gretel is that the energy was bigger to the west of Hawaii. So Kauai would have been even bigger than Oahu on this swell. And this is your 13, 14, 15, 16, 17 second energy. This is through the whole episode. You can see that it started on a Monday, and this is the big Tuesday. Then it was still energetic Wednesday. And here's the 15 seconds. So this is another aspect, is that it's important to utilize the spectral density to fine tune your forecast, and also keep in mind the jitter that you're going to see. And that's always the challenge to the forecaster, is that on a given, are you forecasting for a 12-hour period? Are you going to forecast what those maximums are suggesting? Or are you going to forecast what the average or the minimum? So that's always a daunting task. Everyone has their own opinion on how you need to define a policy. And I'll leave it at that, is that everyone has their own opinion. I want to step into that trap. Anyhow.
Excellent. Wow.
So that's my story, and I'm sticking with it.
We have a question from John. So he's asking, if you know the fetch area, like the coordinates, can you forecast for times at your area, say approximately what time it will hit at, say, Sunset Beach?
Yes, it all boils down to the spectrum, as I mentioned, is that when you look at the fetch, when you have to use the criteria of the number one is what is the wind magnitude, because if you have only 30 knots, you're going to get a fully developed seas. You can only do so much with 30 knots. You're going to get about 15-foot seas. You can only do so much. And the dominant wave period is going to be around 12 seconds. So you're so limited by what the magnitude of the wind is. So for the given magnitude of the wind, if you can get near a fully developed sea, so say your typical large wintertime, deep low pressure, it gets down below 970 millibars. You have a vast area of severe gales, which is on the order of 40 to 50 miles an hour. Is that as long as you can have enough fetch length and duration, that you can get what's called a fully developed seas. And for that fully developed seas, there's a set known dominant wave period. And that known dominant wave period is your what you're going to bank on for doing the travel distance estimation. Because as I say, it was the dominant energy was 17 seconds. It travels 600 nautical miles a day. Because the system was, say, roughly 3 times 6 is 18. So it's 1,800 nautical miles out. That's roughly up 40 north near the date line. That's a super common. That was the last weekend swell. Up there by the date line, it's going to take 3 days to get here. So, that was like Wednesday night, Thursday night, Friday night, Saturday night. So that's kind of when that one kind of came in was Saturday night. So you can just quickly make an estimate on the arrival time just based on what the fully developed seas are. So all aspects of science, no matter biology, whatever it is, you always have to simplify it to a model. And what the surf forecaster has to do is to simplify it to some sort of fully developed seas where you can name a dominant wave period, and you'll use that dominant wave period to estimate the travel time. And then you'll use the seas and the wave width and the distance to travel to estimate what the swell height would be off your shore.
Okay,
Did that help answer the question?
I think so.
If not, I'm glad to restate it.
Yeah, so we talk about this in the Pacific Desk training. So basically, like what Pat's saying is from if you have a fetch with a certain wind speed, the 30 knots he's talking about, then your dominant period is going to be about 12 seconds, right?
Yeah, 30 is about 12 seconds.
Yeah, right. So you know your average 12-second wave travels at what, 400
Roughly 400 nautical miles a day.
nautical miles a day, right? So then if you know how many nautical miles away your fetch is, then you can calculate what your time.
That's like today, looking at the charts, we got that low up at 35 north, about 800 nautical miles away. We got those 30-knot winds seen in the ASCAT last night. 2 days from, it's today, Tuesday, so Monday night, Tuesday night, Wednesday night. Thank God for fingers. I'd never be able to do surf forecasting. So Wednesday night is coming in.
Okay, so we have another question from Salipa. Okay, any alternative observational method available to verify surf forecasts if there's no buoy in the area, in addition to altimeter obs and scatterometer? So yeah, this is part of the issue for a lot of our students. There are no buoys. So, and there are no buoys necessarily upstream of where they are in terms of the swell. So what would you do in that kind of case?
You have no other choice but to blindly follow the wave models. And then just, if you have a history of following the wave models, you would know the biases. Sometimes they give you more, sometimes they give you less, sometimes they bring the long period energy in too soon. So there's all those, but that would be the aspects where experience, you would gain a knowledge base and be able to look at the wave model data and give your best estimate of what you think as the expert when the waves will arrive and how big they'll be.
Yeah, and I would say from my experience in Guam, being sort of in a similar position, because there's the nearest buoys are right offshore. So yeah, you just keep checking the altimeter observations. That storm surf site, Pat showed a figure of that. So that'll give you the Wave Watch 3, and it'll have the altimeter overlaid on top of it. So you can see how well that matches up. Yeah, and that's about what you can do, I think. Does anybody else have any other questions? You can ask through chat, or you can just ask vocally. Okay, everyone else is shy. Either Gary or Pat, either one. Any questions?
I was gonna say one time surf. I don't remember when it was, but it was probably about 8 years ago. Out of spot, a kind of a secret spot out by where I live. It's an outside reef along the southern shore, and I remember the buoy readings were 2 feet and then 20 plus seconds. You know, the spectrum was, it was really long. So, you know, it was hovering. The forerunners, the initial forerunners were 20, 22-ish, and then up from there and then down on the spectrum. But I went out at this place in the evening when it was coming up, and there were 10-foot faces. So that spectrum, that long period in the spectrum, was magnifying the swell 5 times. And I'll never forget how impressive that was. And I've seen it, Pat, and I'm sure you have too, on the North Shore when the same kind of spectrum, super long. In other words, it was a storm force gale fully developed, 4-foot seas at 20 plus seconds at sunset will be cracking the outer reefs and can crack outside pipeline in this deep water with only 4 foot of swell. Have you seen that, Pat? You know what I'm talking about? Those deep water, the swell periods are more important than the swell size almost. I mean, they are.
You have to have all surfers are going to be akamai. I mean, have knowledge of the swell period. It's critical.
Critical. I mean, I could have drowned out there on a 2 foot swell.
Okay, well, if nobody has any further questions, we'll post this, like I said, on our own webpage, the Pacific Desk webpage later on. And I'll also try to include links to Gary's page, of course, and then some of the ones that Pat referenced too. So thanks everybody for joining us, and we'll hopefully see you in maybe 2 or so weeks for satellite.
Mahalo.
Yeah.
Thank you for putting this together, David.
Thank you, David. Good to see you, Gary.
Yeah, we'll see you out there.
Shake that sand out of your hair.
Okay.
Oh, yeah, yes.
By the way, it's a foot outside. You see it? It's 1 foot, 9 seconds. Okay.
All right.
Aloha. Take care.
Take care.